Good morning. Hope you've had a enjoyable break thus far. So we're going to do our SAT prep online, and I'd like you to take out this sheet right here that has the review of exponents and the rules with them. Not on there is what happens multiply, when we multiply um, exponents with like bases. This is a quick review I want to go over because it's going to be useful um, in the coming pages. So when you have like bases like x and x, like bases, but different or even the same exponent, doesn't matter. When you multiply like bases, the rule is you add those exponents and keep the base. Keep the base. I mean, technically what we're doing is we're multiplying the coefficients on these. So there's a hidden 1. 1 times 1 is still 1. Keep the base. And then it's the exponent plus the exponent, so m plus n. So if we look at an example down here, the reason why this works is because, well, what does it mean to square something? It means take your base and multiply it by itself by the exponent that many times. So x squared is really x times x. And because we're doing multiplication, we're going to multiply x times x by x cubed, which is really x times itself 3 times. And if we look at this, it's this new product is x times itself 5 times. So it's really x to the 5th power. That's why this rule applies, that when you have like bases, like x and x, what you're really doing is you're just adding the exponents because of this expanded form. See, this is the x squared, this is the x cubed. I'm saying this is going to be equal to x to the 2 plus 3 power, to the 5 power. Well, yeah, there's 5 x's, therefore it's x to the 5th. Okay, and here's a little hint: when in doubt, expand the terms and see what's happening. It's always true. Math, you can't break. So let's quickly go over some examples here following this rule. Well, in here, all the bases are the same, 2. So this will be 2 to the 4 plus 5, that's 9, plus 2 power, 11, 2 to the 11th power. So all 2's, exponents are added. Coming down here in example 2, this is explaining that idea. Yeah, you have a like base, b and b. It's just you have different quantities of them. In this first term, we have 7 b's. And in the second term, we only have 1 b. So following these rules, we're going to keep our base, b. We're going to add the exponents. 2 plus 5 is that 7. But to get the coefficient, we're going to multiply our coefficients. It's 7 times 1, which is 7. And you can read this. You can pause the video and read this if you want a little explanation. Let's go to number 3. So in number 3, I quickly do a visual check. A, and A. I know I'm going to keep my base, A, and to figure out what it's raised to, I just add the exponent. So it's 2 plus 3 is 5, plus another 3 is 8. And that's where we get A to the 8th. Now here, in number 4, it's the same rule, all right? Let's check if we can use our rule. All the bases are x. So when I simplify this, it's going to be x to some power. And the rule is when you have like bases, you simply add the exponents. So it's 3 plus a negative 2, right? 3 plus a negative 2. That's the same as 3 take away 2, which is the same as 1. So this becomes 1. And then we have this 4 left over. So then it's 1 plus 4, which is this 5. All right, and that's where we're getting x to the 5th. So be careful when adding negative exponents. It's subtraction, okay? And then down here, this is kind of the penultimate example. We have like bases, a, but different coefficients. So let's do with the coefficients first. 6 times 5 is that 30. To figure out what a is being raised to, we keep the base and add our exponents. 3 plus 4 is that 7, and that's where we're getting 30a to the 7th. So knowing how to add exponents when you have like bases will be quite important with the lesson. So now that we got that out of the way, let's move on to our lesson on exponents with fractions and negatives. You can review this if you like, but let's move on. So exponent review. Ignore this little piece here. the expression x to the n means it's the base x multiplied by itself by the exponent, by n times. So here, in number 1, my base is 4, and my exponent is 2. So it's 4 times itself 2 times. That's what's really going on. It's 4 times 4, which is 16. Here, my base is 2, and it's getting multiplied by itself 3 times. So that's 2 squared. This is what we call 2 cubed. 2 raised to the 3rd power, which is, well, let's do one step at a time. What's 2 times 2? That's 4. So that's where this is coming from. Then we have that 2 left over. It's still multiplication. 2 times 4 is 8. So 2 cubed is the same as 8. And then coming down here, our base is 3, and it's getting multiplied by itself 4 times. So it's 3 times 3 times 3 times 3. And I'm going to do this a little bit more creative. This is 9. This is 9. So this problem is really 9 times 9, which is 81. 3 to the 4th power. 3 to the 4th power is the same as 81. And you can kind of see this this expanded form and these tricks. Multiplying chunks and then keeping that multiplication and multiplying other chunks will be a common theme, and it's especially useful tactic in SAT prep. So let's move on to what happens when we have 0 exponents and negative exponents. Now, the rule with 0 exponents is anything raised to the 0 power is simply 1. There's only one exception, is when x equals 0. X can't equal 0. 0 raised to the 0 is undefined. We don't know how to do that. So just keep that in mind. So 6 to the 0. Well, it's a base raised to 0. My base is non-zero, so it's 1. 7.25 raised to the 0. 1. Pi raised to 0. 1. X raised to 0, 1, with the condition x can't be 0. 1 million raised to the 0 power, 1. Doesn't matter. Anything raised to 0, so long as it's not 0 getting raised to 0, is going to be 1. So that's a trick they'll try and do. They'll try and say, they want you to think 3 raised to the 0 is 0, or it's itself. 3, and this is garbage. This is basura, trash, okay? We're not going to be fooled by that. Now, coming to raising to a negative power. All the negative, we're speaking language here. All it tells you is turn it into a fraction. Take your base, all right? We're going to take the base, and we're going to make that our denominator with the same power, So that negative, what the negative is really telling us to do is say, take 1 and then take our base and the exponent and put it in the denominator. So here, okay, let's do it in blue. This negative is telling me make a fraction with my numerator 1. Okay, and then it's saying stuff this and this in the denominator, 3 to the 1st. So simplified, it's just 1 over 3. Okay, so coming down to the next one, 3 to the negative 2 power. All right, once again, this negative is telling me make a fraction, and then take our base and the exponent, put it in the denominator, 3 squared. Notice when I rewrite this, the negative is gone because that negative was consumed in making the fraction. So when I simplify this, it's really 1 over 3 squared. Well, that's 1 over 3 times 3, which is the same as 1 over 9. Okay. Coming here, 3 to the negative 3rd power. So the negative tells me, put it as a fraction, and then just rewrite my base and the exponent. So 3 cubed, all right? That's 1 over, I'm pretty bad at math, so let's expand it. 3 times 3 times 3. All right, that's what it means to cube something. Well, 3 times 3 is 9, still times 3, well, that's 27. So this is really 1 over 27, all right? 3 to the negative 3rd power. 3 to the negative 3rd power is really 1 over 27, okay? Remember, negative exponent tells you to put it in the denominator. Make a fraction, 1 over your base to that power in the denominator. So 2 to the negative 4th power is 1 over 2 to the 4th power. Okay? Well, once again, I'm pretty bad at math, so I'm going to expand this. 2 times 2 times 2 times 2. 2 times itself 4 times. Well, that's 4. This is 4. We're still multiplying. Well, that's 16. This is really 1 over 16. So this is a nice review of the rule with zero exponents and negative exponents. To recap, anything raised to the 0 power becomes 1. Anything raised to a negative power becomes that base in the denominator raised to the same power, but just positive now. All right, the last piece, okay, and this is kind of the most complete one, is let's talk about when we have a base raised to a fraction, and they're going to use m and n, okay? I'll color coordinate this a little bit. M and n, okay? So this says the expression x raised to the mnth power means that, oh, this is a bunch of gibberish, whatever. Let me just show you, okay? So this thing will equal, take your base, write it down, that's going to stay the same. And then you see how the m is the first thing, the first term that we're going to be looking at? That's saying raise your base to that power. So this is really x to the mth. And then the denominator, the n, well, that's going to come out on the radical. Whenever you have a fraction, it's a radical, and it's saying, oops, I inherently did that. Put this to the nth root. This is pronounced nth root, and then this is pronounced mth power. Okay, so the numerator is going to become the power of our base, and the denominator is going to become the nth root, what kind of root we're taking of our base. So the fraction is a combination of raising the base to a power and then taking a root of that very same power. Okay, the most frequent fraction you'll see, fractional power, is 1/2 power. So when we say 1/2 power, that's the same thing as square rooting. Okay, the fraction tells us to use a radical, and then the 2 in denominator tells us we're going to do a square root. Right? So when you raise something to the 1/2 power, it's really the square root of that base, because we're taking our x and raising it to the first power, and then when we square root, there's a hidden 2 there. That's why it's a square root. Okay, that's the logic. So if we look at example 1, I mean, you can kind of see my model here if you want a little refresher, okay? If we look at example 1, how do we evaluate 4 raised to the 3/2 power? Well, I'm going to rewrite this, okay? I'm going to take my base 4, and rewrite it. And I know my numerator, okay? My numerator is what that base is getting raised to. So it's really 4 cubed. And then the denominator, that denominator becomes what power I'm taking the root of. So it's the square root. All right? So let's evaluate it. Let's go underneath the radical first. Well, 4 cubed is the same as 4 times itself 3 times. That's the same as, well, this becomes 16, so that's the same as, and I'll keep this square root, okay? That's the same as 16 times 4. Well, 16 times 4 is 64, and we're still taking the square root. So what this number out here is really saying is squaring, right? When we square, it says take the base and multiply it by itself 2 times. Okay, when we square root, we're saying instead of taking the number and multiplying it by itself, we're saying what number, when we square root, what number times itself will give us the thing under the radical. All right, so x is the thing that you can multiply by itself, right, square rooting, to give us x squared, the thing under the radical. So here, 8 is the number that I can multiply by itself, right? That's square rooting. What number times itself will give me the thing under the radical? 64. 8 is the number times itself that will give me 64. So if we were to take the cube root of 8. What this is saying, what this is saying is, what number times itself 3 times? 1, 2, 3 times. What number times itself 3 times, right? The radical tells me what number times itself. The cube root tells me 3 times. All right, what number times itself 3 times will give me 8? Well, the cube root of 8 is 2, and that's because 2 times itself 3 times gives me, well, 2 times 2 is 4, and then 2 times 4 is 8, right? So that's kind of the cube root. That's what this number outside of the radical is telling us. Whenever you don't see a number there, you assume it's a 2. Just like when you have x, you obviously know the coefficient on it is 1. It's a hidden 1, okay? So in conclusion, let's take a look at example 2 and tie this all together. So let's apply our rules. So I immediately notice I have a negative for an exponent. So that I know. That's the first thing I'm going to deal with. It tells me write this as a fraction. So now what goes in my denominator is my base and then the positive version of that power. So it's 2 to the 5 over 2 power. All right? So that's 1 over, let's rewrite this, this fractional exponent. My base, keep it. I know this first term is what my base is going to be raised to. And then this second term, the denominator of my fraction, is the power that the root is raised to. So I'm taking a square root of 2 raised to the 5th. Okay, well now that I got that, 2 to the 5th power. So I'm going to drop this 2 because I know it's a square root. Well, that's 2 times 2 times 2 times 2 times 2. If you got a calculator, use it. Right, I don't. So I'll show you my trick. 2 times 2 is 4, times 2 times 2 is 4, and then don't forget that 2. Well, 4 times itself is 4 squared, which is 16, and then we're still times 2. Oh, that's 16 times 2, that's 32. So this is really 1 over the square root of 32. If you can simplify radical 32, I would simplify it. Let's see if I can do that on the fly. Let's see. 30, oops, turn it on. 32 divided by 4 is 8. I can do another one. Oh yeah, this is obvious. Boom. That's 16 is a factor of 32, so it's really 1 over. I'm going to break up this radical 32 in a product of radicals, so it's radical 16 times radical 2. And then I'm going to simplify. Well, radical 16 is really 4, so this is really 1 over 4. Right? That's what radical 16 becomes, 4 radical 2. Hopefully this was informative. If you have any questions, rewind the videos, pause it where you need, and then sometimes seeing examples is just the best way you can learn this. So get a feel for what's going on, and then try the examples, the concept review. And in the next YouTube video in this playlist, we'll be going over, I think there's 15 problems? Yeah, we'll be going over all 15 concept review problems, so I'll see you there. Thanks.